This is the second part of rates of change in Introduction to Calculus. And we are looking at this f of x equals x squared form of a nonlinear equation. Now, what Mr. Autry's done here is he's chosen an x value of 3. And what we'd like to do is we'd like to find out what the gradient is right there at 3. Well, if we go just to 4, we're going to get the number between, let's see here, between 3 to 4, that's a run of 1. And between 16 and 9, it's a rise of 7. Well, that's 7 over 1. That's our first approximation. It's actually not exactly going to be that, but it's reasonably close. What would happen if we moved this closer, a lot closer, just from 4, if we moved it down so that it was only a tenth? If this was only a tenth, well, if we take 3.1 and we put it into the calculator, we square it, we get something like 9.61. I'll believe Mr. Autry. And then when you subtract, you get 0.61. 0.61 over 0.1. Hey, that gradient is now 6.1. It's getting closer to 6. It's a better approximation. But what would happen if we, instead of making it 0.1, we made it 1/10,000th? So this is just a tiny little piece here. Okay, like 3.0001. If we only move just a tiny little bit this way, then this part, well, let's see what it would be. If you take 3.00001 and you put it in, you square it, you'll get this really tiny number. It might not be this one. But anyways, if you took the rise over the run, you actually do get this number here. It's 6.0001, which is incredibly close to 6. The big deal is the smaller we make this, the better approximation we get of what the gradient's going to be right at that one point. That's the big idea. And here's the last one. Instead of thinking about real like a tenth or a minute, we just think about it as h. And this 3 plus h squared, because we square it, this is h, 3 plus h. If we square it, we get 6h plus h squared. Well, there's our rise over our run. 6h plus h squared is the rise, and we factor out h. Hey, it equals 6 plus h. We factor out the h's cancel. Take a close look at this in your notes, because here's the big deal. Here's the real punchline. If we're taking the limit as h approaches 0 of 6 plus h, well, if h gets incredibly close to 0, that gradient just becomes 6. And that's the whole idea. In fact, later on, you get this. This is the first principle thing of a gradient. F of x plus h minus f of x over h. If you let h approach 0 and take the limit, you're really finding the gradient right at that x value. That's called f prime of x, or the derivative. And that's what it's all about. It's called the derived function. It's called the derivative. It's the rate of change of y with respect to x, anywhere on f, for any x value you want. It's the gradient anywhere on f. It's all those things. Well, you need to look at the notes really carefully, and hopefully my words helped a bit to explain it all. I hope so. We'll see you in the next video.